Hi everyone, in this video we are going to learn proof of Pythagorean triplet. To proceed with the proof, let us consider a right angle triangle with the vertices A, B and C. This triangle is angled at C. So what is the proof? First of all, let us know what we have to prove. Yes, the Pythagorean triplets are 2mn m square minus n square and m square plus n square. We have to connect this with the right angle triangle. So taking the largest side and rewriting the expression as 2mn the whole square plus m square minus n square the whole square should be equal to the largest side, which is m square plus n square the whole square. So we are supposed to prove this hypotenuse square is equal to sum of squares of other two sides. That means the largest side should be m square plus n square, and let me take this side as m square minus n square and this side as 2mn. When we apply Pythagoras theorem, hypotenuse square is equal to sum of squares of other two sides. So this is what we have Pythagorean triplet. So we need to prove this. So let me consider a triangle, a right angle triangle, same notation A, B, C. Since the sides are not known, I'll denote one side as X, Y and Z, or we can use ABC also. To proceed with applying Pythagoras theorem to this right angle triangle, so triangle ABC, hypotenuse square, that is Z square, can be written as X square plus Y square. Ultimately, we have to arrive at this result because this is the proof, the required proof for Pythagoras triplet. So now, rearrange this term. Y square will be equal to, Y square will be equal to, I can write this as Z square minus X square. Y square is a product of 2y. Can I write it as y into y? Here we can use the basic identity a square minus b square for further simplification, which can be written as a plus b into a minus b. So instead of a I have z and instead of b we have x. So I can rewrite this as z plus x into z minus x. The next step, a small simplification again. We'll take y, this term to the denominator. Y by z minus x is equal to, in this case I am taking y to the denominator, z plus x by y. A small simplification. And we are very sure whenever it is in a fractional, we should make sure that the denominator is greater than 0. It cannot be equal to 0. The condition, the denominator has to be greater than 0. Throughout this proof, the denominator terms will not be equal to 0. So next step, I can rewrite this as y by z minus x is equal to z plus x by y. Let this be equal to m by n. Same condition, the denominator should be greater than 0. So further simplification. You can see here the terms are equal to, first two terms will be equal, second and third will be equal, which implies the first and third term can also be equal. I'll take this as first term, second term and third term. So now equating the first and second term. So first term we have got it as first term and third term. Y by z minus x will be equal to m by n. Take the reciprocal. Z minus x by y is equal to n by m. This can also be written as z by y minus x by y is equal to n by m. Or I can write z by y is equal to n by m plus x by y. I'll take this as fourth equation. Already 1, 2, 3 we have given a notation, so I'll use this as fourth one. So first and third we equated. Now we will equate second and third term. So I'll do it by the side. So second term and third term. So let's go back and check what is the second term we had. It was z plus x by y is equal to m by n. So we will use the same term here also. Z plus x by y is equal to m by n. This can also be written as z by y plus x by y is equal to m by n. We'll take this as fifth equation. So we are very clear. Fourth equation, z by y is equal to n by m plus x by y. And fifth equation, z by y plus x by y is equal to mn. So now the next step. From equation 4. So what was our equation 4? Z by y is equal to n by m plus x by y. Let us substitute this term in equation 5. So what was equation 5 then? Z by y plus x by y is equal to m by n. So in place of z by y, I will substitute n by m plus x by y. So what we get then? N by m plus x by y is equal plus x by y is equal to m by n. Simplification. N by m, both are like terms. When I add, we get 2x by y is equal to m by n. So let me retain only 2x by y. So when I do that, so what we get now? 2x by y, 2x by y, 2x by y is equal to, shifting this, m by n minus n by m. We can simplify the RHS by taking LCM. So 2x by y is equal to, so the LCM becomes mn or nm. Cross multiplying, m into m becomes m square, n into n becomes n square. I don't want this 2, so I'll shift 2 also. So it's x by y is equal to m square minus n square by 2 times mn. We will retain this as equation number 7. And here also we should have a condition that m and n should be greater than 0. Only then the proof is valid. Now going back to the fourth equation. So what was fourth equation? So according to the fourth equation, we have z by y is equal to n by m plus x by y. So right now we got x by y value. So we can substitute. So what we get? N by m plus m square minus n square divided by 2mn. Take LCM. 2mn becomes LCM. Cross multiply. So it becomes 2. M and m cancels out. N into n becomes n square. Plus same term is the LCM. So we will retain with only the numerator. So that is m square minus n square. So 2n square minus m square, on simplification we get n square. So I can write z by y is equal to m square plus n square by 2n. I'll take this as equation number 8. Now compare between equation 7 and equation 8. What we observe? The value of y. You can see that the value of y in both the expression, remains the same. So what is the value then? The value of y in the expression is y is equal to 2mn. It is fixed. Now check the numerator part. So what is x from here? M square minus n square. What about z? M square plus n square. So going back to our diagram, we got the values of x, y and z. So when I go for our right angle triangle, instead of x we have got it as m square minus n square. Instead of y we got as 2mn. Instead of z we got it as m square plus n square. So the sides values are known. Now we can apply Pythagoras theorem that will satisfy the proof of Pythagorean triplet. So what is the largest side here? We have z square. So I can write as m square plus n square the whole square is equal to, what are the other two sides we have? The other two sides are m square minus n square the whole square plus 2mn the whole square. This is the required proof and we have derived the formula for Pythagorean triplet.